So welcome Year 10 to our 6th video tutorial for our flipped classroom. So we're going to be starting a new topic for the next 2 weeks. As always, you will have me on a video tutorial, a PowerPoint to help you, plus we'll be going over our homework in class when I see you next. So let's have a look at our new topic and what we're doing today. The topic we're going to be looking at is rates and ratios. So today's video and the next one is going to cover part 1, ratios. So what do we need to revise? Firstly, what is a ratio? Secondly, how do we write ratios? Third, how to simplify and find equivalent ratios. And lastly, how to solve ratio problems. So what is a ratio? A ratio is 2 or more numbers that compare the parts of something in the same units. Each number in a ratio is called a term of the ratio. And lastly, operating with ratios is very similar to operating with fractions. We can see a good example here, that the colour green can be expressed as a ratio of 2 equal parts, 1 part blue and 1 part yellow. And we would write this ratio as 1 to 1. Again, a ratio must be expressed in equal parts. 1 part blue and 1 equal part of yellow would make green and be expressed as a ratio 1 to 1. Cordial is something similar that we can express as a ratio. It's made up of 2 things, or 2 parts: cordial concentrate and water. Now if we were to measure each part as 1 tablespoon, we could express the ratio of cordial as 1 part cordial and 15 parts water, making sure that each part was equal, that is 1 tablespoon. So how do you use the ratios and why do we use ratios? Sometimes a ratio will help us to find the quantity or the amount of something. For example, in a school, the ratio of teachers to students is 1 teacher to 18 students. If the college has 80 teachers, how many students are there? Secondly, sometimes you'll be given quantities and need to express or write them as a ratio. For example, if Mr. Stinson is making a cake using 1 cup of flour, 1 cup of sugar, half a cup of eggs, and 2 cups of milk, what is the ratio of each ingredient to each other? So let's look at what we're actually doing today. Before we start ratio problems, we need to do 2 things. The first of these is to find equivalent ratios. The word equivalent means the same or equal. So firstly, it is easiest to deal with ratios if both the ratio terms are whole numbers. To find an equivalent ratio, a ratio that is the same as another, we need to multiply or divide each ratio term by the same number. I've got 2 examples below. Let's look at the first one on the left. The ratio you've been given is 2 to 7. We need to fill in the blank here to find an equivalent ratio where the second term is no longer 7 but 35. To do this, look at the 2 known matching terms, 7 and 35. They're matching because they are on both, or they're both on the same side of the colon in the ratio. So we look at what has happened to 7 to become 35. In this example, 7 has been multiplied by 5 to give an answer of 35. So if this is the case, we need to do the same thing to the other term, 2. Therefore, 2 times 5 is 10. If you look below, we can see that our new equivalent ratio of 2 to 7 is now 10 to 35, because we multiplied both terms by the number 5. Now let's look at the example on the right. We need to find an equivalent ratio for 12 to 8. An equivalent ratio where the first term is now 3. So firstly, look at the two known matching terms, 12 and 3. They are matching because they are in the same position on the ratio. So what's happened to 12 to get 3? We've divided 12 by 4. Therefore, if we are dividing 12 by 4 to get 3, we need to do the same thing to the second term, 8. 8 divided by 4 is equal to 2. So below you can see that our new equivalent ratio of 12 to 8 has become 3 to 2, because in this case we've divided both of our original terms by 4. 12 divided by 4 becomes 3, and 8 divided by 4 becomes 2. We'll do more examples of this in class. The next thing we need to look at this lesson is simplifying ratios. This is very similar to fractions. The rule states that to simplify a ratio, we simply divide both terms by the same number. And remember, this number has to go into both terms evenly. So let's look at the example below on the left-hand side. We have been asked to simplify the ratio 24 to 16. First step, look for a number that you can divide both of these terms by evenly. I know that I can divide 24 and 16 by 2, by 4, or by 8. These three numbers will go into each term evenly. Ideally, you want to divide each term by the highest common factor. So if the three factors were 2, 4, and 8, go for the highest one, 8. So to simplify the ratio, 24 to 16, we divide both terms by 8, and our simplified ratio becomes 3 to 2, or 24 divided by 8 is 3, 16 divided by 8 is 2. So let's look at the example on the right hand side. Let's simplify the ratio 18 to 30 to 15. First step, we look for a number that we can divide each of these terms by evenly. If we look closely, the only one number that we can divide each of these terms by evenly would be 3. So to simplify our ratio 18 to 30 to 15, divide each term by 3, and our simplified ratio would become 6 to 10 to 5. Next lesson we're going to look at ratio problems and how to solve them. So take some notes. We'll be doing lots of practice of equivalent and simplifying ratios in class. Look forward to seeing you then.